Good morning, ma'am. Hello. Hello. Ma'am, is it audible? Hello. Ma'am, is it audible?
Yeah, it is audible, but they are not in line.
Okay.
Now you tell me, can you hear my voice?
Yes, ma'am.
Hello. Okay, good morning to every one of you.
Good morning, ma'am. Good morning,
Okay,
ma'am.
how many people are there? Good morning.
Good morning, ma'am.
Good morning. How
Ma'am,
many of you are there?
10 people,
Good morning.
excluding 10 people, ma'am, including you and
Including
the host.
Okay, can we start? Let us wait for 1 or 2 minutes.
Your wish, ma'am.
Any regular students have strapped in, or all regular students have joined already?
Harshita
Everybody
is
has
not.
joined, ma'am. Harshita is not. Yeah, Harshita is not there.
I have, she knows that today we have class. We'll wait for another 2 minutes. Durkesh, your voice is not clear. Okay, let us wait for 2-3 minutes.
I think 10 people are.
Yeah, it is 10:30. I have to know that. We only send the schedule now. Okay, we'll wait for another 2-3 minutes or 5 minutes. If
Harshita
nobody
came,
gets-
ma'am. Harshita also
Okay.
came, ma'am. She joined.
Okay, thank you. Any regular students have come means we'll wait, otherwise we'll start shortly.
Okay, ma'am.
We'll start, ma'am.
All regular
Okay,
students, ma'am.
Okay, then no problem. Very good. Appreciate you people. Okay. Anyone can tell me that in last class what we have seen? Don't say that we don't have last class, please.
No, ma'am. Aerators, ma'am. Different type of aerators. Gravity type, diffuse type, spray type, sedimentation.
Exactly last class what we have seen. After aerators, we have seen one lesson, no?
Sedimentation, ma'am.
Sedimentation, ma'am.
Okay, that lesson name is called sedimentation. What you exactly have studied or you learned?
Ma'am, about
Hmm.
types of sedimentations, ma'am.
Okay. Any another term I have used? Any some other term or some other concept you people have learned in last class?
Viscosity.
Huh?
Viscosity, ma'am. No, ma'am.
The concept of the lesson, what did you study in the last class? What did you not study? What did you learn? What concept do you learn in the last class? People. You people are grown. Otherwise, I will ask you all to put lean now. We have studied about flagellation, flagellator, na?
I was going to say coagulation and flocculation also we did,
And
ma'am.
about the mixing type, how we are
Yes,
feeding and
ma'am.
exiting in mixture. And
Yes,
mixing is an important process of coagulation and flagellation.
Yes,
Without
ma'am.
proper mixing, how it will affect the entire process efficiency, I said, isn't it?
Yes, ma'am.
Then we have seen what are the purpose of doing coagulation, what are the factors affecting the coagulation, then mixing, how it is important in flagellation process, then type of flagellator we have seen. Isn't it? Hello?
Yes, ma'am.
So in this class, what is according to the different stages of water treatment, next to the flagellation, what we supposed to do? What could be the next stage of process? After flagellation, what we have to do?
Filtration, ma'am.
Before filtration, what we have to do?
Sedimentation.
Sedimentation, coagulation, flagellation are all interrelated, all are same.
Yes, ma'am.
Next to flag, once a flag formed, we have to separate the flag and what is that process?
We have to separate. Through some medium, we have to separate the flag.
Okay, what is that process name? How does it name it? That is very, very important question. It may be 4 or 5 lines will be there in your book.
Flotation.
Flotation is another type of method of separation of floatable particles or suspended particles from water. I am asking, once fog formed, we have to separate the clear water from the fog by the same settling process. What is that particular process name called?
Ma'am, hindered and compression settling. Hindered settling and compression settling.
And that is type of settling. What did I say?
Okay.
All my students are so clever. They are trying maximum to confuse me. Very good, Putru. Excellent. I told you many times this is very, very important question. In your book, only 4 lines are there, but they will ask that question in a big question. How to answer to that question also I have said. Okay, next class onwards, I will have the scale to beat you people. Okay. That process is called clarification.
Clarification.
Understand? I have told you repeatedly that that is very, very important question, but much more information is not available in your book. How to answer to that question also I have told you. When I will explain about the clarification and the clarifier repeatedly like a repaired record, I have told you. People, please, once the class over, you just have a read of half an hour. It's more than enough to recollect the subject. Otherwise, this is something very technical. You people will be facing problem before your exam. It is my kind advice to every one of you, please. Understand? Okay. So after clarification, what we have to do? What? Everybody is muted or what?
No, ma'am. Okay.
Okay, unmuted. Very good. What is the next process of clarification? What you have to do to gain the knowledge of water treatment, whatever I have mentioned about the different stages of water treatment in lesson 4, from the screening to plain sedimentation, then aeration, then coagulation, then after that coagulation, flagellation, then clarification is not explained. I have explained more. Then conditioning, mixing, then only flagellation will come. They have not mentioned like that. After that, clarification, that is also not mentioned that. Then filtration. After filtration, disinfection. After disinfection, they are sending the water to the common water supply. Then they are distributing the water to the end use point. These are all the different.
Can you tell the alignment once again, ma'am? Once again.
It is there in your book, ma'am, and I have explained everything in detail. What are the major steps of water treatment and what are the auxiliary steps of water treatment? For everything, I have given an explanation. What is that? Some of the information are not there in your book. I have given extra also. Okay, I will tell you one more time. After you finding the water source, you have to take the water from the source to out, either from dam or river or stream or whatever it reservoir, whatever it could be. From the stream or dam or river, directly you cannot the water for distribution, because there will be n number of problems involved due to the pressure and the quantity of water available and the quantity of water supply. So what we have to do, once you find out the source of water, you have to take the water from the river to river outside. For that, people are using intake works. Okay. I am like a repaired record. I am telling you, people just hearing and forgetting. I don't know. I think I am not explaining properly. Answer to me.
No, ma'am, you're explaining very properly, ma'am. There's a gap. 1 week, no, ma'am. Maybe that is why.
No, once we revise, no, everything will get recollected.
That's what I said.
You're telling perfectly, ma'am.
Once the class over, just to open your book here and there, you read for half an hour with your notes. It is more than sufficient. Half an hour is more than sufficient to read. Read, I said, not study. To read means get an idea. If you have any doubt, you can clarify in the next class. Okay. Yeah. Until or otherwise you work on water treatment process or project, it is quite difficult to follow. I know that. That's what repeatedly I'm telling you people. Okay. So once you take the water from the source to intake, then from the river water, dam water, how it could be, we know that. I told you for your easy understanding, any animal bodies, including human body or part of the body or whole body, any plants, branches or whole trees also may be there. These are all possible things to be available in that water. So what people are doing once they got it, water from the source, they just screen it. First process is screening. But you remember whatever I have mentioned. In this screen, they are removed the very bigger particle like trees, debris, animal, branches of trees, bushes, and something like clothes, this, etc., whatever it may be. Those screens are classified into two types. One is coarse screen, another one is fine screen. Fine screen is very fine wire mesh people are using for, but when the large scale, when you are using fine screen or fine filter media, it will be clogged, it cannot be used continuously. So this kind of waterworks, people are using coarse screen only. How it is worked here, people are making the parallel iron rod. They are placing between 2 to 10 centimeter gap, center to center, and they are placed vertically sometimes, or it is based on some of the angle horizontal with the horizontal. The angle may be varied from 40 to 60 degrees centigrade, which depends. So this is about the screening. After screening, if the water contains lot of organic matter, if they feel, then they are allowing, after screening, they are allowing into the preliminary settling tank. Preliminary settling tank, which is nothing but plain sedimentation tank. Okay, in plain sedimentation tank, they will not do any sort of treatment. They just allow the water in still condition without any disturbance of water. So whatever the things are substance which are all higher than the water density, those particles or those substances will be settled down at the bottom. That is called plain sedimentation or settling. Then they are taking out the water. Here, that auxiliary methods are coming. Times also you cannot understand. If you read it, book also it is quite difficult to get it. If further, if the fine organic matter, but they are very complex in structure, those kind of particles are there in water means people have to do aeration process. Why we have to do aeration? If the water contain lot of dissolved gases and some organic matter are there means this aeration process will eliminate or remove these dissolved gases, that is in the form of carbon dioxide, methane, hydrogen sulfide and ammonia. And it is supplying air or oxygen to the water. So whatever the organic matter in water will be oxidized or converted from the complex structure to simple structure of organic matter, which is useful for further step of treatment to make it simple. And sometimes what will happen, if the water contains lot of hardness, then what they have to do, they have to remove the hardness. While they are removing the hardness by following alum or some other method, the pH of water may be coming down in acidic way. So to make the water to be normal or a removal of this hardness again, softening process has to be done for adding of lime or something. Okay, this is softening. Suppose sometimes the water contaminates too much. There is a large quantity of microbes in the form of bacteria, virus, fungi, algae, whatever it may be. At that time, the pre-disinfection process or pre-chlorination process is required. That means what? Before doing all the treatment, that means before coagulation process, people doing chlorination process, coagulation process, chlorination process they are doing to reduce or to bring down the infectant to some level. That is called pre-chlorination. In case sometimes the water may be colorful, not plain water, but some of the color will be developed by some presence of some material or mixing of sewage or something like that. We can't say because of what. If you want to remove that color and sometimes the odor also, if you add activated carbon, that will absorb the coloring substances that makes the water to be free from the color. That is called activated carbon treatment. The last 4 treatment which I said, aeration, softening, pre-chlorination, and activated carbon treatment, these 4 methods are auxiliary method. When I have explained all the method, I would have told you that clearly. If the water contain more organic matter, if the water pH is acidic, if the water contaminated too much, if the water has color, then only these 4 treatment needed to be done. So it is called auxiliary method. If these characteristics are not available, none of the method will be applicable or required. If any one of the character is available, the respective treatment method will be adapted to do the treatment. Understood?
Yes, ma'am.
Okay. Then what people are doing, now we have removed bigger particle, whatever can be filtered it off, I have done. Now further in water, further in water, the particle which are all called colloidal particles. Any one of you have done what is meant by colloidal particle? I have told you to do some testing. Any one of you have done?
With Colgate, ma'am. Yes, ma'am.
How it was looking?
Ma'am, little frothy, but small bits were there.
Okay. And then that frothiness will be stopped after some time.
Yes, ma'am.
So those particles could be absorbed, but can you, do you think that those particles can be removed by any filtration technique?
No, ma'am.
No, ma'am.
Nothing can be done. Nothing can be done. Okay. But those particles are there in water. Anyone like to drink?
No, ma'am.
Those kind of particles.
No, ma'am.
Those, okay. I think only Nubia only has done that work. No one has tried. Others are not there in the class.
I tried small particles of that paste are settling at the down also. They're sticking.
No, it will not settle. Ma'am, it will not settle. For your kind information, if you would have dissolved properly, it would have not settled down.
Might be that. Might be the reason.
Okay. Otherwise, it will not be concluded as a colloidal particle. Understand? No, for your knowledge only I am telling. If it is that, then why they are doing coagulation? Even why they are adding chemicals into the water? Already people are telling that pollution, polluter, chemical, this, that. Then once again they are adding chemical into the water that makes for drinking purpose. You can have those doubts. So to clarify only, I make you to do the test. Then you can understand this water is good, taste is good, color is good, everything is good, but these kind of particles are there. No one will drink. So how to remove it? This is only the technique can be adaptable for removing those kind of particles. And also by grace of God, some chemicals are there. Once we are adding into the water, those chemicals aggregate that small particles into bigger one. It is wonderful technique, isn't it?
Yes,
if
ma'am.
any very wonderful. You can add some alum if you have, then you can observe it. It looks excellently, and which makes some color also sometimes. Based on the nature of the particles which are present in water, light blue color, light pale pink, nice color will develop sometimes. Okay. So what we have to do, those kind of small particles next we have to remove. That is not completely dissolved and it is not completely suspended, which is in the middle form. Those are all called colloidal particles. They are less dense than water. So those particles are removed from the water by following the coagulation process. Coagulation process, which is nothing but you add some of the chemicals into the water. So whatever the turbid particles are there, they are slowly coming in contact with the coagulants. Then they will attract and they aggregate the size into bigger one, and it makes like a gelatinous precipitate. Those are that gelatinous precipitate is called flog. That process name it's called flagellation. So now you have settled down the colloidal particle from water. We have to separate the water from the flag. That process is called clarification. This is being done in a device. It is called a clarifier. Even after clarification, the water contains some of the flag particle. It is possible to go along with the water. Those particles will be removed from the water perfectly, 100% is supposed to be removed from the water. Then only the water looks like a clear water for human consumption. That process is called filtration. About that filtration process only we are going to discuss in this particular class. So after filtration, again we have to do, what process we have to do finally? After filtration?
Disinfection, ma'am.
Yeah, after that we have to do disinfection.
Post-chlorination, ma'am.
Yeah, yes, otherwise we can say that is post-chlorination. What we have to do here? Chlorine we have to supply into the water in the form of chlorine dioxide or free chlorine gas, whatever it may be. Earlier days people have used even bleaching powder also. What is meant by bleaching powder?
Ma'am, bleaching powder is chlorine only, ma'am.
And so what is the chemical name of bleaching powder? This chlorine only. I myself told you, na, disinfection means chlorination. We are adding the chlorine in different form. That bleaching powder is one of the chlorine form. Isn't it? It could be that only, na? No?
Yes,
Didn't get my point.
Yes, ma'am. Yes.
Then what is that? That is bleaching powder is very common chemical, is
Sodium
available everywhere.
CaCO2.
CaCl, calcium chloride. That is
CaO, ma'am.
Ma'am, hydrochloric acid with hydrochloric acid.
No.
Calcium
it's not hydrochloric.
It's sodium chloride or calcium, sodium carbonate or calcium carbonate.
Caustic soda, baking soda.
No, calcium hypochloride. Chloride.
Yeah.
Okay. Google Mother helped you.
Yes, ma'am.
Bleaching powder, yeah. Calcium
So you
hydroxide.
people almost you have told whatever the common chemicals in chlorine form or chloride form. Very good. My students are very excellent. Okay. Calcium chloride means sodium chloride. Okay. The chemical name of bleaching powder is calcium hypochlorite. Okay. Which hypochlorite. And why they are using chlorine gas, chlorine dioxide, even hydrochloric acid also has chlorine, and many halogens also can be used for this purpose. Why they are using bleaching powder then? Understand my question? Have you smelled bleaching powder at any time?
Yes, ma'am.
Yes, ma'am.
It's soluble in water, no, ma'am. But it will not. Will not react with the impurities that is there.
It will not react.
It will kill the germs and disinfect the water.
Remove it.
We are studying about that only, na, to kill the microorganism or germs only. We are studying. My question is, have you smelled at any time bleaching powder smell?
Yes, ma'am.
Yes. What is the smell of it?
Very strong
Uh,
smell.
Some chlorinated type of smell will come and just avoiding water it will come.
Okay, then. Sir, okay. My question is, have you used at any time this chlorinated or bleaching powder added water?
For whitening of clothes, we use no. For cleaning.
Ma'am, tanks is sometimes we see a lot of algae.
Of tanks. Yeah, sometimes.
Chlorine powder, bleaching powder, they add it.
Okay.
But it will not completely dissolve, no, ma'am.
During this corona also, they have kept
it dissolved in water. That's what they are using for disinfection.
Yes, completely dissolve. Yes.
It dissolves in water.
It dissolves in water.
Okay. So now what I have to tell, I forgot really from all you people will answers. Okay, very good. Good thing you have that. Actually, earlier days, this much technology was not available. For example, you consider any village during the rainy season. Once the rain stops means, have you observed at any time, today it rains means, today evening it rains means, next day morning how the sunlight could be, anyone have observed?
The bright light, it will be very clear.
It is very clear. Yes, yes, correct. Your answer is it is very clear because whatever the dust particles are there in the atmosphere will be settled down by the rainfall. Okay.
Yeah.
So that's what the sunlight is very clear. You can observe nowadays also. After rain, some of the people are quite interested to observe it. Today it rains. Tomorrow we will have the clear sunlight. They will say. I have heard it from many people when I was in hostel. Okay, so that means it is settled down all the particles. The why the people are using bleaching powder, especially after rain. Once the rain stops, continuously it rains or during the rain season, after rain stops, clear sunlight or bright sunlight will be there, but we could not observe that intensity of sunlight, but that sunlight will be helpful or which is favorable for the growth of any sort of microorganism. That time, especially in rural areas and undeveloped areas, wherever the common access area by the public people, there the growth of this kind of microbes more. So simply the people will be spreaded this bleaching powder here and there.
Oh.
Have you observed?
Yeah, that is true, ma'am. Because nowadays we see near garbages also, they are spraying bleaching powder.
Yes. Okay, the reason behind that only. Now, the same thing when the chlorine dioxide, other chlorine also do, those are all highly costly. But this is only the technique can be adopted at the very less price rate and which will be done in a excellent way with less cost and which will be adaptable for all sort of people, all sort of places like rural, developed, this, that, etc., whatever it could be. That is the reason they are selecting. Why earlier days for water treatment also they have added this bleaching powder only for water supply system. Have you tasted at any time bleaching powder added water?
No, ma'am.
No?
No, ma'am.
Dahlia madam, you have not in your smaller age? I think she's not in the class or what?
She is there, ma'am. It takes time for her to unmute.
Okay. No,
What was the question, ma'am?
Actually, for drinking water supply earlier days, not nowadays. People add this bleaching powder directly into the water for same disinfection. That water they have distributed in the common water supply systems, especially in rural areas and some of the developed cities also. If you smell it or taste is mint, you could observe that bleaching powder smell and taste. It is difficult to drink or difficult to use it, but they have done earlier days with that technique only for doing that disinfection process. So what is the chlorine content of this bleaching powder? These are all general knowledge, whatever I'm talking. In many exam, people will ask these questions. What is the chlorine content of bleaching powder?
Not more than 10%.
Yeah.
Not more than 10% of the total, I guess.
No, it is available 25, 30, 35, 40, 45 up to that it is available. More than that.
For drinking purpose.
For drinking purpose, final residual chlorine supposed to be 0.02 to 0.03 milligram per liter. If it is more than that, it is problematic. If it is less than that, it is also problematic. I told you now, and there are many classes.
Yes,
got it? That is very, this is also general knowledge. Even it is being asked in ISN exam also. If it's supposed to be in the range of 0.02 to 0.03 milligram per liter.
This is prescribed ISI standard.
Yeah, all the thing chlorine standard is the same only. Chlorine level is same.
Indian medical standard.
Whatever it means, Indian medical standard, IAS, WHO, what is that? Pollution control boards. All people are having the same sort of level only for especially chlorine. Other factors may be plus or minus 10% changes will be there, but in chlorine there is no change at all. They may give average value that they would have taken average of these two value. and they will give sometime between, or they will give sometime minimum or maximum. Like that, they will be expressed in a different way. But the range is same from all the source of water treatment information about the chlorine. Is it clear?
Yes, ma'am.
Okay. So at last, whatever it may be the treatment, the final chlorine level, they have to be maintained between that, whatever the mentioned level. When they are using this bleaching powder also, they could maintain that level. Sometime, because people only what I can unskilled people are using, those who are filling up the water tank, distributing the water supply system, those who are working there are 99% uneducated only. How much water is there in the tank, how much powder they are supposed to be added, they might not be knowing that. And in such a situation, the chlorine level is supposed to be more. And that circumstances in many village, the kids were affected by the diarrhea, something like that. That is true. Then later on, they have reduced. Nowadays also, they are following the same thing, same technique for doing this disinfection in common water supply system in villages. They are adding directly bleaching powder into the water. Sometimes the dose is becoming more also, it affected many people indirectly. Suddenly the effect will not be seen, but later on the effect could be seen. That is the problem of using of bleaching powder. It does not mean that bleaching powder is bad, which gives only bad smell, but the effectiveness is good. Okay, this is the different stages of water treatment. Is it clear, or one more time I have to tell?
No, ma'am, it's clear, ma'am.
Okay, thank you. Anyone has any doubt?
Potassium permanganate also they stopped using.
Yes, because potassium permanganate when you are using, no, which yes, I heard you that potassium permanganate can be the disinfectant, but it will not give 100% duty of disinfection. When we are using that, which imparts the color of that pinkish color in water, that water can be drunken.
Yeah, ma'am.
That is the reason they have avoided. But it is a disinfectant listed. One of the disinfectant. That is correct. Okay, now we will look after this filtration process. Okay, now I ask you the question. How we pass your answer in the question, that much fast we can read the class. What is meant by filtration? Already I have asked you. What is meant by filtration?
Ma'am, it removes suspended particles from the water, ma'am.
The process of suspending the removal of impurities from the particles by passing through some medium which can porous medium.
Okay, this is a process of separation.
It's a physical process. Physical, chemical, and biological, all three processes actually.
All three processes.
Okay. The important term you have to be mentioned, two people have told, Nubia and somebody else said, it is a process of separation of turbid particle or suspended particle from the water or from any liquid. When we are talking about this filtration process, we cannot say this is a physical process. We cannot say simply that is a chemical process. At the same time, we cannot say this is a biological process also. The concept-wise, all the three types of process are involved in filtration process. That worldwide technique you can look up. The process only involved with all three stages involved in filtration process only. We can assume that this is a physical process, that is a chemical process, that is a biological process. Here you cannot say this is that is this, because all three are interrelated. We are saying that filtration is very simple technique. Yeah, you are taking water, pouring and getting. But when you are thinking in a large scale level, in continuous operation, it is one of the hectic process of water treatment. It is very hectic process. You cannot imagine filtration means this much a simple technique. Why she is telling like that? That is very, very big process in water treatment. We will see what are the difficulties of that process. Okay, this process, especially people are using that, remove the suspended or turbid particles from the water by passing through some porous media, whatever it could be the media. It may be physical media or chemical media, or make use of some biological filter media. It can be separated out. And in general, these filters can be classified based on the operation. There are two different types of filters are available. One is rapid sand filter, another one is slow sand filters. From the name itself, we can understand that the rate of process it is involved to classify these two types. Slow means we can say the rate of process is less. Rapid means you can understand the rate of process is high. This rapid sand filter only is commonly used everywhere, especially in all water supply system like municipality, town, cities like that, because which gives large quantity of water filtration, and it can be filtered it up very fast. That's what they named it is like a rapid sand filter. Clear?
Yes,
Then classification of water filters. There are many types of water filters are available. I can say 30, 40 types of water filters are available in rapid sand filters based on many concepts. What are they? There are 4 important concepts are available to classify the water filters. One is what kind of filter media people are used for the filtration process. And the second one is what kind of filtration rate controller they are used for the filtration process, and whether the filtration process is operating under pressure or above the atmospheric pressure. And fourth one is very, very important thing. Anyone can say filter media? That is, what is the flow of water through the filtration media or filtration bed. Based on these 4 concepts, the filters are being classified many types. Means again using the filter media, it is classified. Again based on the flow direction or flow, it is classified. Again the flow control device used, it is classified. Again, you know that about the pressure, there could be only 2 models, under pressure or above the pressure. Above the pressure, when we apply, many system can be employed. So based on the system used in controlling the pressure, it is being classified further. Understood? Okay. Now we will see. Actually, these terms and are little difficult for you people. Wherever you feel difficulty, please tell me. I will explain more. Okay. Then according to the filter media, how the filter can be classified, we'll see. Filter media means what you are thinking. You know some perforated plates, perforated material, through that you are passing like your tea filtration. We are telling that that is the filter media or filter. But really the filtration system which is being employed in water source, it is totally different. Clear? So filter media means what it could be. What do you feel? I am saying filter media according to...
Media means how, through which we filter.
Yeah, the substance or material, what they are using through that, how we are performing the filtration process is called filter media. What could be the material can be used for? We cannot judge, but cruelly we can say the material which are having little porous or more porous and will very fine pore size and the pore volume should have more. Those kind of material can be used for this filtration process, isn't it?
Yes, ma'am.
Okay. So in rapid sand filter in general, the people are using pore size of the filter which is very, very fine. That fine filter or fine size particles they are using for rapid sand filter, which is based on the how many layers of filter media they are using. In general, any filters, they won't use a single layer of filtration media. They use more than 2 or many, or we can say multimedia filters. They layer by layer with a different sort of material they are packing. And at last, in some of the filters, they are making the topmost layer of filter is very, very fine media. Fine media in the sense the pore size of the media is very, very small. And below the layer, the pore size maybe could be little higher than the topmost layer. In some of the filter media, they are using the equal pore size from the top to bottom. In some of the filter media, at the top it is more and the bottom it will be smaller, which is based on the kind of flow system and the kind of flow direction and what kind of pressure they are applying. Based on that, the packing will be different. But in the rapid sand filter, at the topmost layer, the people use the very fine size of pore sized particles. When they are doing like that, at the topmost layer only used for that perfect filtration, and the remaining layers are not used, it is remain unused. So to avoid this situation and increase the efficiency of filtration process, this condition, whatever the mentioned condition, which leads to find out some other type of filters that contains dual media or multimedia. Here what people are doing in this both dual media and multimedia, which needs some of the larger size occupy at the topmost layer, and those particles are very, very thin and lighter. And below that, they are using that very fine size of pore-sized particle. So which leads the flag can penetrate deeper and deeper in all the lower layers. At last, that the efficiency or effectiveness of filter will be very good or more than which achieve the more gradual head loss along the depth of the filter media. What is meant by head loss in filtration process or in any process? What is meant by head loss? I have used the same term when I was explaining about the flagulator also. I thought any one of you will question on me, but no one questioned. So I was in safer side. You didn't hear me what I said?
Head loss, ma'am.
Head loss. Don't say our head will be lost. No.
No.
What is meant by head loss?
Head loss is related to the pressure which will be lost due to the flow of the water through some pipes or any medium.
Yes, correct.
Flow of the water more, I think.
Yeah, that's correct. What you said it is correct.
Evaporation. Loss of volume.
No, I cannot hear your voice. Somebody was speaking. Who spoke?
Ma'am. Loss of water during pumping.
Okay.
And evaporation.
Where the loss is occurring? Where the loss is occurring? Where the loss is occurring?
On the peripheral area, ma'am.
Pressure, ma'am, pressure.
No, ma'am, pipe while transferring from one place to another place.
Yeah, that's all. Okay. When the flow system is occur, the water is supposed to be flowing from one flow to another, one end to another end. If is there any struggle in the flow, that means how the struggle will come, something somewhere which blocks the flow. Then the water flow will be reduced.
It's not about loss of water, ma'am. It is the pressure.
No, I tell you, please. Yeah.
Ma'am, your voice is getting stuck, ma'am.
When my voice is getting stuck now.
Now we can hear.
No, that means my signal become weak. I think today also is going to be rain. It looks like that. Whether it rains or not, that I don't know. Okay, leave it. Now I'll tell you very clearly. Then you ask your doubt. When the water flow system is occurring, water is flowing from one end to another end. It's supposed to flow freely, means there will not be any pressure increase or decrease or head loss. If the water flowing, whatever it is flowing at the inlet, it's supposed to be equal at the outlet. If it is not happening like that, somewhere something is stopped the flow of water. That means there the pressure will be developed. Where it is stopped, there. Understood? In that particular point, the pressure will be developed and the flow of water system is reduced. That is called the head loss. From the head, whatever is coming, it's supposed to be reached to the tail. It is not reached, something is stopped. Where it is stopped, there the water becoming stagnant due to that pressure is developed, which affect the system, especially filtration system. It will be affected very severely for the further process. That why it is called head loss, because the filtration media, filtration system supposed to be porous. When it is flowing through the filter bed, whatever the turbid or colloidal or fog particles are there, those supposed to be absorbed in the filter media and the clear water supposed to be coming out of the filter media. When these particles will be settled on the filter media, and there is a method how to recover the filter media from this absorbed fog that I will explain later. But when the fog is continuously sit on that pore, and when the filtration process is continuous, so this porous media will be blocked by the fog particle. It means in the continuous filtration is not taking place. It is blocked. So wherever it is blocked, the water flowing will be stopped. If the water flowing is stopped, but the inlet is pumping the water continuously to the filter media or filtration process, the pressure will be developed in wherever the water logging is there. That point it is called head loss. Understood?
Yes, ma'am.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. Anyway, who is asking the question? Durgesh, is it clear for you? He's not in the class.
He is there, ma'am.
Durgesh, are you clear?
Maybe he went somewhere.
This is the problem of online classes. You people will enjoy like anything. Okay, good. Where I left this, that is called head loss. This will occur in any process. When you are doing that flocculation, clarification process, coagulation process, I said no.
Yes, ma'am.
There, everywhere, wherever the water flowing system, if any sort of hindrance is there on the flow, the pressure will be developed, the flow will be stopped. That is called head loss. So in a filtration system, that is one of the major issue when they are operating the filters. Clear? Okay. So this kind of problem is huge in multimedia and dual media of filtration system. So what is meant by dual media and multimedia filters? From the name itself, anyone can explain clearly?
Ma'am,
I
first
think dual media uses two mediums, ma'am.
Two medias used for
many
filtration
mediums.
and
Okay.
many.
Okay. Durkesh, you were not in class for some time. Did you understand about this head loss? He's not hearing my voice or what? Okay, leave it.
Unmute only, ma'am. But I think we can't hear his voice.
No, he was talking a few minutes. Okay, leave it. If he has doubt, let him ask. Dual media means from the name itself, what you people said, that is correct. The people are using two different media. Okay, not two media. Two media can be the same also. So technically, when we are speaking, we have to talk very clearly. That is two different media. Understand? So when we are doing this process or making this dual filter media, what are the factors supposed to be considered? So what are the factors for filter media? That is very important. One or two places you people study and the rest of the places you just read and understand. Okay. In first case, I will tell you. In dual filter media, generally which is composed of forced coal upper layer. The upper layer they are using coal. Coal, have you seen coal at any time? Any one of you?
Coal.
Yes,
What
ma'am.
burn and cook, ma'am?
But don't say about the charcoal. Charcoal is different from coal.
Okay. Coal, no, ma'am.
It looks like
Ma'am,
a
you
stone.
asked something, ma'am. Ma'am,
Like a
hello, my
stone.
network is. Hello,
Yes, tell me.
ma'am, you were asking something.
Yes,
Ma'am, my network is going off and on, ma'am.
Okay, fine. I asked you, did you understand about the head loss?
Yeah, ma'am. I understood, ma'am.
Okay, fine. Okay, now I'm asking what is meant by coal. Have you seen anywhere coal?
Ma'am, in some
Coal, ma'am.
Coal, not charcoal.
Ma'am, it looks like a
Coal,
stone.
Okay, color?
Coal
Color
mines,
is
ma'am.
grayish
Color
to
will
black.
be
Grayish to black.
grayish to black, yeah.
Okay. So those coal particular, somebody said it is stone. It's something like a stone, very little hard, but the inner surface is little soft, which has lot of pore size and pore volume. We can say lot of pore volume with fine pore size. That is correct explanation. Okay. When we grind those particles, we can make it as a coarse coal particle. They can be used for this making of filters. And that so in dual filter media, they are using this coarse coal particle as the upper layer, topmost layer. And what are the types of coal? There are different types of coal. Then they will say some name, you should not be confused. For that only I am telling now. What are the different types of coal? I have told you in class many times.
Ma'am, one is bituminous coal.
Very good.
One is lignite, ma'am. Lignite
Okay,
coal.
very good. Okay, then.
Anthracite, ma'am.
Anthracite. Okay, very good. You have answered these three very good. Okay, there are 4 or 5 types of coal is available based on the carbon content. The coal is being graded based on the carbon content only. If it contains large quantity of carbon, that is the topmost quality. If it contains less quality, means that is the bottommost quality. The topmost quality coal name is called anthracite. The next grade is called semi-anthracite. Next to that, it is called semi-bituminous. Next to that, it is called subbituminous. Subbituminous, both same only, bituminous. And the fifth one is called lignite. And below that is called peat, P-E-A-T, peat. Peat is commonly very less uses than the other types. The topmost quality is required more for all the process, but the availability is less. But the topmost middle level lignite is more. Lignite availability in India is more. That grade only most probably people are using India for making the power generation in thermal power plant. All the coals are having carbon content more than 40 to 50% to 80, 85, 90% of carbon. If the carbon content is good, that coal is looking little hard, and inner surface supposed to be very soft because which contain lot of pore volume. That means the porous nature or porosity or pore size is good. So that could be
Which is the softest coal, ma'am?
Softest in terms of carbon content means I can say it is anthracite, but it looks very hard. Understand?
Not bituminous.
It looks very anthracite. You know, I will clarify. These are all the types of coal. Any type of coal can be used based on their porosity and pore volume. You know, diamond is very hard or soft?
Diamond is very hard.
Very hardest stone, ma'am. Hardest material.
Hardest material.
Graphite is, I think, soft. Graphite is soft.
Soft. Graphite is soft.
Okay, this anthracite is in between these two. Understand?
Means, ma'am, the coal which is having the lower carbon content is soft, ma'am.
No, it is material wise, it is softness. But we are talking about the porous and porosity, pore volume, pore surface area, no?
Okay, it's not. It doesn't depend upon carbon content.
I told you the anthracite is looking very hard outside. It looks like I told you that it is in between graphite and diamond. The hardest carbon in the world is what? What is the hardest carbon?
Diamond.
Diamond.
How it looks? That is looking that means which contain lot of carbon. Which is the carbon rich product in the world? That is also diamond only. What is the color of diamond? What is the color of carbon?
One is translucent to transparent, and one is black or gray.
Okay, now I will ask you, based on the carbon content, we are classifying this coal, graphite, and diamond. If diamond color is in black color, will you buy?
No, ma'am.
I will say that this is 100% pure diamond, and even I can certify also. I can prove it also. But will you buy?
No, ma'am.
Why? That is pure only, na?
Looks
diamond.
Look beautiful.
Diamond is colorless, no, ma'am.
We are also talking about the same only, Durgesh. I am asking a very critical question. That contain lot of carbon, pure carbon. We can say 99 to 100% carbon. Then only it became like a diamond, isn't it? The carbon only became a diamond, isn't it? The carbon level when it keep on increasing, then the diamond it forms. Now I'm asking you, the diamond looks like a carbon color. Will you buy? Because our peat and lignite, which contain 40 to 60% in the range of carbon, which looks like very pale carbon. Somebody told me that which looks grayish to blackish color. When the carbon content is increasing from peat, lignite to anthracite, the color is also becoming dark, and it is slowly becoming hard, and the pore size is becoming very fine. Clear? And when it reaches from anthracite to diamond, the carbon content still it is increases more and more, and the substance is becoming very hard. The carbon content is more means you are telling that is the purest and the topest product of containing largest quantity of carbon means. If it is in black color, why you won't buy? You can buy, no? It is 100% carbon, that is called graphite or diamond you are telling. Then why you are not buying?
It is
Visually appealing,
it is not it is not to polish, no, ma'am. It has to undergo some process of polishing.
So what exactly happening in polishing? Yeah,
Polishing
people come to the point. If people came into the point, are coming into the point, what exactly is going on in polishing?
Polishing means a coal will be converted to.
Is being removed, ma'am.
The carbon which are there.
There may be some procedures to remove.
Okay. Now, I will give you this is the homework because about the combustion I only taught you. Okay. Now I am giving this is a homework for you all. Not only Nubia or Asha or somebody else has to do. Everyone should do. Okay. That is called homework.
Maybe they are heated to high temperatures.
That now only I told you combustion. Okay.
Combustion. That's right.
You got it, I understood. You are all very clever. Yeah. You got flooded out anywhere, people will grasp it. Okay, you note it out. You people do it as a homework, and when you are coming into the next class, not in today's class, next class you have to answer. Okay, I may forget, you people have to remember. Nubia,
yes,
you please remind me.
Okay, ma'am.
Okay, these people may forget. I may forget, I'll tell you the truth. Okay, we'll come to the point, very important things which I am going to tell about the media. And coarse coal they are using as an upper layer. Whenever the people are using are selecting the material for making this filter, the filter media is supposed to have good specific gravity, and the effective size supposed to be good, and uniform coefficient of the particle. That is very, very important. And up to what depth you can use this media is very, very important. What is the topmost layer? What is the bottommost layer? What is the uniform coefficient, and everything supposed to be maintained very properly in this filter media. Is there some sort of difference will come? Then it is a problematic in terms of head loss. Then entire filtration quality will be going down, and entire filter efficiency becoming zero. Because of that, pressure will develop. If pressure will develop, which will affect also other steps of process of treatment. Because the filtration is involved almost in the final stage of water treatment. If it creates back pressure, that back pressure will be build up the pressure in the previous stage of treatment, then it will be affected, even it is giving an effect in the intake process also. So to avoid all those processes, this filtration process is taking care of very much in water treatment stages. Okay, and I told you that the topmost layer is coal, which has the specific gravity of 1.5 to 1.45 to 1.55. Effective size supposed to be 1 to 1.6 millimeter. Uniform coefficient in the sense the uniformity of the size of the particle or shape of the particle is supposed to be 1.3 to 1.7. It is very, very important when you are making the compaction of the substance in the same media. And the depth also, they are using different sort of depth for different media. For this particular thing, they are using between 0.4 to 0.7 meter. And the top of, actually, I told you that the coal, they are using the top layer. Below that, they are using sand layer in the dual media filter. The sand media, simply we can take the sand, we can fill it up. It is not possible. When you are choosing the sand, what kind of sand you can use, what kind of specific gravity which has, what is the effective size of the sand particle, what is the uniformity of size, depth, and everything would be measured properly. For everything, there is a standard physical parameters are available according to the ISI. Based on that only, this would be selected and packed and they are using. And the specific gravity of the two materials are different. The two layers retain their respective position after that backwashing. Backwashing means what? I told you that already. When the flog is separated or filtered through the filter media, the flat particle will be going and sitting on the pore. So if it is keep on sitting on the pore will be blocked. Wherever the pore will be blocked, there will not be the flow of water. So that keeps the or maintaining the pressure buildup. That is only I said it is a head loss. When it is happening over the period of time, then how we can use the filter continuously. So for that, the filter wash is important after the filtration process. One of the important stage of washing of filter is backwash. Backwash means, have you done any time after making the tea, will you clean the tea filter from the front side or back side? Or both side we are doing, isn't it?
Both sides.
Yes, ma'am.
Okay, we are doing backside now. That backside means whatever the particles are sitting on the pore will be going away by the water pressure. That's what we are doing, that back pressure. If you normal way, you will keep using the 1 liter of water. By the backwash with the 10 or 100 ml of water, you can clear it off very fast, isn't it? Have you observed? Have you done? No, no one made tea. Okay, very good. I will tell you how to make tea. People, you are not laughing, Aris. You're not feeling shame.
We made tea, ma'am.
Okay.
Yes,
When
ma'am.
yeah, I'm telling important concept which is involving in your tea filter wash and this backwash of filters. When you are washing your tea filter, there will not be any head loss. There will not be any problem of locking. There will not be any loss of media, isn't it? Especially when you are using steel strainer, no problem at all. I am asking the question, when you are washing the filter in the front side and the back side, what could be the difference in operation you have observed, or what could be observed? You got my point. I answered a few seconds before.
The front part you get coarse material, and at the behind part you get finer particles maybe.
Okay, correct. While washing a filter.
No. While straining.
Okay, that I understood. That's what I asked the question while washing. When you are washing the water filter, tea strainer,
yes, ma'am.
Both side you can wash. Front side also you can wash and back side also you can wash.
Yes.
When you are doing washing both side, what could be the difference in operation of wash at the front side and back side?
Front side particles are electric. You do it from the back side, they are washed away, ma'am, generally.
Your voice is not audible. Look at your signal. Bhargavi.
I think two medias.
A few minutes before I myself have answered to you.
Hello?
Yes, tell me, please.
It is clear, ma'am. From back side, if you wash it, whatever are leftovers also will go away, ma'am. Like if you wash it from back side, whatever is left from washing from the front side also, if you do it from back side, there are also left, even the thinnest particles.
Anyone of you here heard?
Ma'am, can't hear properly.
Yeah, my voice is not coming out.
Yes. Bhargavi, sorry, we could not hear your voice. But you are trying to say something. Okay, I will answer to all of you. Now, today itself, people try whether I am correct or wrong. You take the tea strainer. After making tea, you throw in your tea dust. Then you take it for washing. Many people would have not washed. That's why they didn't know that. Okay, I agree with you all. Today, please, for trial, you try. From the front side, you just try to wash. What will happen? Some of the things will be clear it off. If you do the washing from the back side, you are pressurizing the water from the back side. Whatever the particles stick on the filter inside will be coming out very fast. Both sides it could be washed, but the effectiveness of the back wash will be better than the front side wash. Understood? So
Yeah,
that concept.
I think it is because it is passing through two media.
No, I am just telling about the washing only. It is
Okay,
not I am not talking about the filtration. I am talking about the washing of tea filter. Okay, whatever the tea strainer you have, you just wash it from the front side and back side. You find out the difference. From the back side, it will be easy. Whatever the sticked particle will be coming out faster than the front side wash, which consume less water than the front side wash. The same technology people are using here, but when we are coming into the point of filter media, when you are doing this wash, the wash should not affect the filter media, because washing is a very important stage when you are flowing the water on the filter media, which will make the pit on the filter media, because some of the media will be coming out. We know that these are all the packing of some porous material. The porous particle, if you are providing turbulence at any pressure or any agitation on the filter bed, it will be making the particle to be loose in the filter media, so the particle may come out. Understood? So to avoid all those things, in general, or 90% people are following the backwash system only. Backwash means from the backside of the filter, they are passing the water slowly. Then the water level is started increasing slowly in the filter media. Then whatever the particles, fog particles are clogged or blocked in the pore of the filter media will be slowly coming out. Then it is coming up slowly. It will be washed continuously over the period of time. Then they will check the concentration of fog in the first time, or periodically they are collecting the water. They are checking the concentration of fog in the water. Once it maintains, there is no fog or stability it maintains, then stop the backwash. This method will be effective method, or this is only the method can be adopted for washing a filter. Then you have to take out the filter, you have to dry it. That is called regeneration of filter media. Again, you can use it for filtration process. Did you understand?
Yes, ma'am. I just shared a picture. Just see if this is correct.
I didn't receive anything till now.
No, ma'am. Is it not sharing?
It is visible, ma'am. I'm able to see.
Okay. We can see. We can see, ma'am.
Okay.
Filtration process and backwash process.
I did this yesterday, day before yesterday only.
Okay.
You can't see, ma'am.
Assignments. Ma'am, you can hear me?
Your voice is getting stuck, Bhargavi. Ma'am has disappeared.
I have not disappeared. My God, my students are so great people. I could not see your slide. I will see later. I will tell you. Okay.
Okay,
don't
ma'am.
waste
I'll
your
send you a
time.
picture.
Okay. So that is whatever is topic on this matter I am telling. It is very, very important. Understand?
Okay, ma'am.
Then what are the advantages of this dual media? Anyone can tell? Which increase the filtration rate because only 2 layers and they are very effective. And therefore, there is a reduction in total filter area cost and everything, because longer filter rate are run at any given loading and the feasibility of increasing at low cost. These are all the important points to be used or considered when the filter is using for long time or in a commercial water supply system, isn't it? In economical point of view. And the advantage is the most accepted common method in USA, UK, and other developed countries also, this dual media system. And the very important thing I would like to, this common information and all, you people please read it. Sometimes people are using high grade bituminous coal and also crushed coconut shell, sometimes crushed berry seeds and the kernels of apricots. Those are all the material can be used for this coarse. This coarse material can be used for this dual media. Not only coarse coal, high media or high grade bituminous, and whatever the seeds and the kernel of a shell I have told, those are all that can be used in the combination of bituminous and that. The dual mixed in media that is composed of cold coarse material as in the form of coconut shell that has a size of 1 to 2 millimeter, and which has the mixed layer of 30% of sand and the mixed bottom layer of 30% of sand and boiler clinker. Boiler clinker means anyone can say what is that? Which is found in many developed countries, which reduce the head loss compared to the other filter, other dual media filter. You know what is meant by boiler clinker? Boiler means, you know, what is clinker? No one is from any industry. How many of are they? No industrial people are they? Hello?
We don't know, ma'am, who is from industry.
Okay, leave it. Silting means what? Anyone can understand?
What, ma'am?
Salt. What is the term used for in general if the salt deposition will happen? I have not known when we are talking about that hardness.
Yes, ma'am.
Scaling.
No. Scaling. Yes. Scaling, ma'am. Scaling. Yes.
Okay. So out of scaling, something will be deposited in the boiler. Those will be removed. That is very highly porous material. And also it is very, very hard because the people are making steam at what temperature? We can't say it's supposed to be more than 100 degrees centigrade. If the pressure goes up, the steam temperature also goes up more than 1000, 1200, 1500, which depends on what temperature steam is required for generating the power. It may go up to 1500, 1600 also. So at that temperature, the substance are retaining without any melting, means how much it would have been hard. Those kind of hard material, they are using with the combination of 30% of this sand and bituminous coal, which gives better efficiency than any other type of fuel media filter. That is the point that we wanted to say. So people are preferring in developed countries like USA, UK, and those people are selecting this dual media filter for water filtration process. The reason behind that is which creates or which gives very less head loss and the filtration efficiency is more. Filtration efficiency means how we can decide the filtration efficiency. What does it mean by filtration efficiency?
More
proper flow, ma'am.
More impurities it will.
So now I will ask you, Asha madam, one question. Now you are using your filter bed for quite a long time. You are not doing because sometimes what will happen when we are passing the water into the filter media, knowingly, unknowingly, or accidentally, the pressure of the flow is more, means which makes the pit of filter media. That means some of the filter media is coming out in that particular place, the pit will form. And it is happening quite a long time, means and then the pit size will be keep on increasing and it makes more number of pit also. That if more pit is there, the water flow through the filter media will be good or more. So what you can say, according to you, it makes the more flow of water through the filter media. So
yes.
Does it mean that the efficiency of filter is more or high?
No, ma'am, we can't say that actually.
Okay, what is the definition of filtration?
It's a separation of impurities, ma'am, from.
Yeah, that means it is supposed to remove the impurities from the water, and which takes some time. Within a short period of time, how maximum you can separate the particle, which depends upon which gives the efficiency of filter media. Isn't it?
Okay.
Everywhere you have to reinterrelate what you have learned. Then only it will be useful. Otherwise, it is useless. Okay. You know the definition. You know the definition of filtration. What is meant by filtration? It is a separation of solids or turbid material from the water. This you are performing when you are flowing the water in through some filtration media or filter media. So you have to remove the particles and you have to get the good water at the bottom of the filter media or another end of filter media. So the filtration efficiency here, it depends upon how nicely you are separating the particle from the water and how early you are doing. These two factors are involving and efficiency of filter. When you are operating any system where the economy is involved, where you are spending less cost, which gives more efficient way of giving this filtration rate, that gives the better result. So the efficiency of filter media, filter, anyone can define now what is what? Durgesh? No, he is not in the line. Okay, leave it. Anyone else? Hurry, everybody is muted.
No, ma'am.
Okay, fine. Okay, what that means the efficiency of filter is
efficiency, ma'am. It is, the amount of, I mean to say the percentage of particles, which can be stopped, or retained. Which can efficiently retain the impurities particles, ma'am.
Ma'am, you asked something, ma'am.
Yes, yes. But how could you define the efficiency of filter?
It is the percentage of the impurities which can be which the filter can stop, ma'am.
Your voice is breaking. Your voice is breaking greatly.
One second. My network is giving problem.
Okay, I will tell, then everyone can hear me, okay? Okay, then you people think about it. Any controversies there, you can ask me at any time. Now, filtration, filter efficiency means how effectively which removes the fog particles over the short period of time, which gives less economy, is called efficiency of filter. Understood? How we effectively remove the particle? How did you just? The concentration of particle which are on the inlet of the filter and the concentration of solid particles which are at the outlet of the filter will give the difference in solid concentration of water over the specific period of time. Okay, then how much area of filter you have used for time period, that gives the efficiency of the filter. Okay, is it clear?
Okay, ma'am.
Okay, ma'am.
Okay, then we will.
Efficiency will be calculated in terms of ratios, right? Means
I told you now, over means what? It is ratio
100, right?
will not come. It is always efficiency will be calculated in percentage. Whatever the value I said, into 100 gives the efficiency. That's all.
By 100,
that is standard. No need to give like a first class students, you multiply it by 100, which gives 100% percentage. Okay, you have to understand that. Okay. Then next one is multimedia filter. From the name itself, it could be say that they are using a number of material to make this media, filter media. Specifically in this multimedia filter, when they are using it for commercial use, which has 5 different layers. What are they? The first layer, they have polystyrene, which has a specific gravity of 1.04. The second layer, which is anthracite, which has a specific gravity of 1.4. Then crushed flint sand, that is 2.65. Then they are using fused alumina. Alumina means what? Aluminum oxide, okay, which has a specific gravity of 3.8, and garnet, which has a specific gravity of 4.2. They are making the topmost layer with polystyrene, then it is with anthracite, then it is with crushed flint on sand, then they are used with the fused alumina, then they are using camel. Here, what you can observe, anyone can say, the topmost layer has the less specific gravity. When the layer goes down, the specific gravity of the particle is keep on increasing. What does it mean? The finest, the topmost layer has the finest pore size. When the layer goes down, the pore size of the media will be gradually increased. That means the fine particle will be Observe, then slowly, slowly, slowly it is happening like that. At last you are getting that fine quality filtered water. But this is very good type of filter, but this type of filter is not yet be commercialized anywhere. The reason behind that is making or packing of this kind of filter is very difficult. And another important reason is it is very, very difficult to procure or collecting of all these porous media to make this required quantity of water supply like this kind of town or city. Is it clear?
Yes, ma'am.
Okay. Now, can you say, can you write what is the classification of filter according to the filter media?
Yes, ma'am.
Okay, fine. Shall we go to the next one? Then, according to the rate of filtration, how the filters can be classified?
Ma'am, this the basic difference between filtration and distillation is that the distillation we are separating two different liquids, and filtration is completely only one type of liquid, no, ma'am?
Yeah, distillation means distillation. The name itself, we have to heat liquids. That yeah, we can say that is all. In the distillation also will be involved separation of solid and liquid and liquid and liquid. In distillation process, in distillation process the technique is based on the boiling point or melting point of particular component of liquid or solid. In filtration, this is also the method separation of solid and liquid by separation of filtration through the porous media.
Yeah.
Here, based on the particle size you are filtering. So different size of porous material, if you can use different size of particle will be filter it out. There is no concept of melting or boiling point in filtration, but distillation is 100% involved with the boiling point.
Yes.
Okay. Yeah. Boiling followed by condensation is distillation. Not only boiling. Boiling followed by condensation is distillation.
Condensation is release of final release of gas.
Yeah, vapor into liquid, that is called condensation. You are making the vapor out of liquid, then again you are making the liquid out of vapor through the same process simultaneously, that is called distillation. Okay. Filtration is separate phenomena, distillation is separate phenomena. Okay. Liquid also can be separate, liquid solid also can be separate in distillation. But in filtration, you can separate only solid and liquid.
Solid and liquid.
Okay. Clear?
Okay. Yeah, I was. Both concepts were actually merging, ma'am. That's why I got. Because in
no, this is actually, I appreciate you. This is very good question. In many exam like that also people have asked. All the option they give, all the option will you confusing you.
Yeah, ma'am. These two, actually in my school time, I learned the fractional distillation in my school time. So I got confused the filtration and distillation, how the difference is there.
Filtration is a physical chemical process.
Yeah, I got it.
Distillation is thermal process.
Yeah, I got it.
Okay. Okay. Then shall we go to the next? According to the rate of filtration, how the filter could be declassified? What is the time?
This class is yours only.
Yeah.
Okay. Can you give a little small break, ma'am? Saturation point reached.
No, 12:30 to 12 to 12:30. Oh, already 12:30. Yeah. 12 o'clock. Okay. 12, then I stop now. Okay, fine. 12:30 will start. Even I myself forgot. Okay, I'll stop now. We'll start at 12:30. Okay.
Okay, ma'am. Because nothing is getting in the head now.
I not at have breakfast. I have to have breakfast now.
Now we have to use bulk media filter.
Huh?
To take in more lessons, we have to use bulk media filter.
Okay, very good. Okay. Then we'll start after half an hour. You people will come and join, okay? Don't expect me to join. Once I'll come, we will have class immediately.
Okay, ma'am. Thank you, ma'am.